Hello. In this video, we will see what is a neural network, how neural networks work, and what are the mathematical calculations going on behind the neural networks. I will keep the explanations as simple as possible so that even a beginner can understand the concepts fully. So please watch the video till the end. Now watch the data displayed on the screen. X is the input and Y is the output. When this data is observed carefully, the human brain quickly starts getting trained on this data and tries to find out the relation between X and Y. In this case, Y equal to 5 times X plus 3, and the right answer is 53. Our human brain is made up of neurons, like showed in these images. Neural networks are just an inspiration of the neurons in the human brain. Let's try to solve the same problem using an artificial neural network. We will use a very simple neural network to understand the mathematical calculations. The data contains a single input and a single output. So our neural network also has a single input neuron, X, and a single output neuron, Y predicted. Every neural network is constructed of several hidden layers. Each hidden layer, in turn, has several neurons. In this example, we will consider just a single hidden layer, which has a single neuron, H. Note that the number of hidden layers and the number of neurons per hidden layer are decided by the developer, so they are called hyperparameters. All these neurons are connected, and each neuron has a corresponding weight parameter and bias parameter associated to it. For example, neuron H has weight parameter W1 and a bias parameter B1. Similarly, neuron Y predicted has weight parameter W2 and bias parameter B2. Output of each neuron is calculated by multiplying its weight parameter with its input and adding the bias to it. So in this case, output of the hidden neuron, H, is calculated by the formula H equal to W1 times input X plus B1. Similarly, Y predicted is calculated as W2 times H plus B2. Now let's see how this neural network gets trained. After a successful training on the given dataset, the neural network should be able to produce output Y predicted as 53 when input X is given as 10. In order to achieve this result, the neural network should learn the relation between X and Y predicted. In other words, we can say that the neural network should learn the correct values for the weight and bias parameters involved in the network, such as W1, W2, B1, and B2. So in short, neural network training is all about learning the correct values of weight and bias parameters. These parameters are also called as learnable parameters. To begin with, the neural network assumes some random initial values for W1, W2, B1, and B2. Let's say all these values are initialized to 1 in the first iteration. Then the input values are passed into the network one by one. When X equal to 1 is passed into the network, first the hidden layer is calculated by the formula H equals to W1 times X plus B1. The hidden layer output is 2 in this case. Then Y predicted is calculated by the formula Y predicted equals to W2 times H plus B2. The predicted output of the neural network for the first iteration is 3. This entire step is called as a forward pass. From the original dataset, the neural network knows that the output Y when input X equal to 1 is 8. So there's an error of 5 between Y and Y predicted when input X is 1. Similarly, we must calculate the errors for other values of X and gather the errors. Once all values of X in a batch are processed, we should calculate the mean squared error for this batch. Mean squared error indicates how well the neural network is performing and is called the loss function for this neural network. The lower the mean squared error, the higher the neural network performance. Ideally, the mean squared error should be 0. That's the goal of the model training. Now we will see how the neural networks adjust the values of W1, W2, B1, and B2 in correct direction. In every iteration, the gradient of the loss function with respect to the weights and biases are calculated. Using these gradient values, the network knows in which direction the weights and biases should be changed such that the loss function goes towards 0. For example, if weight value W1 is inversely proportional to the loss, then W1 is incremented gradually until loss becomes 0. Similar step is done for W2, B1, and B2 in each iteration. This process is called gradient descent. Next, we will see backward pass calculations in detail. During backward pass, the network needs to calculate the derivative of loss with respect to weight and bias parameters. First, let's see the calculations for W2. Since loss is associated with W2 through Y predicted, we can calculate derivative of loss with respect to W2 by the formula derivative of loss with respect to Y predicted multiplied by derivative of Y predicted with respect to W2. This is called chain rule. Then we get the following result when we take derivative of loss with respect to Y predicted. With the formula of Y predicted, we can also calculate the derivative of Y predicted with respect to W2. Combining these results, we get the derivative of loss with respect to W2. Now let's see the calculations for B2. Since loss is associated with B2 through Y predicted, we can calculate derivative of loss with respect B2 by the chain rule formula mentioned earlier. With the formula of Y predicted, we can also calculate the derivative of Y predicted with respect to B2. Combining these results, we get the derivative of loss with respect to B2. Now let's see the calculations for W1. Since loss is associated with W1 through Y predicted and H, we can calculate derivative of loss with respect to W1 by the chain rule formula involving Y predicted and H. With the formula of Y predicted, we can also calculate the derivative of Y predicted with respect to H. And with the formula of H, we can also calculate the derivative of H with respect to W1. Combining these results, we get the derivative of loss with respect to W1. Now let's see the calculations for B1. Since loss is associated with B1 through Y predicted and H, we can calculate derivative of loss with respect to B1 by the chain rule formula mentioned earlier. With the formula of Y predicted, we can also calculate the derivative of Y predicted with respect to H. And with the formula of H, we can also calculate the derivative of H with respect to B1. Combining these results, we get the derivative of loss with respect to B1. Once derivative of loss with respect to all weight and bias parameters are calculated, then the network will calculate the new weight and bias parameters for the next iteration. For example, new W2 will be calculated by the formula old W2 minus learning rate, alpha multiplied by the derivative of loss with respect to W2 calculated earlier. Learning rate alpha is a hyperparameter, meaning it should be decided by the developer. It's usually set as 0.01. Learning rate is the speed at which the neural network training happens. It should not be too high, as network might miss the optimum value of weights and bias. Similarly, new values for B2, W1, and B1 are calculated. In the next iteration, these new values will be used. This process is repeated until the mean square loss becomes ideally closer to 0. Note that each iteration is also known as epoch in neural networks. Now we'll execute this network in Python code. We create the input and output data. We initialize the values of weights and biases as 1, like we discussed in our example earlier. We set the learning rate as 0.01, and we start with one epoch. Then we write the code for forward pass. These are the same equations like we saw earlier. Then we write the code for backward pass. These are also the same differential equations we discussed. Next, we write the code for changing the weights and biases based on the learning rate. When we execute this code, the loss is 547. When we try to predict y for x equal to 10, we get output as 20. We know that the actual output is 53. This wrong result is due to a big loss of 547. Now we will try to set the epoch to 10 and see if loss becomes 0. Great, the loss has reduced to 1.5. Now when we try to predict the new y, we get 51 as output. When we set the epoch to even higher number, eventually the loss becomes closer to 0. Now when we predict the new y, it gives the accurate result as 53. Performance of a neural network is based on several factors, like the structure of the neural network, initial values of weights and biases, learning rate, etc. In reality, the neural network consists of several hidden layers and several neurons per hidden layer. There are also other concepts like activation function, batch normalization, and dropout layer, which helps in neural networks performing better. If you want to know about these concepts, please drop a comment, subscribe to my channel, and stay tuned. Thanks a lot for your attention. See you in another video.